Welcome ROS2 learners. I am Vijay and this video I am introducing you to the program structure of ROS2 node and some basic information about the node class. We shall also use the default packages and the nodes to publish the message, and at the last we will use the code of the default node to create our own package and run the executable. We shall also touch in brief the changes required in the package.xml and setup.py. There are many important things in this session, so let's get started. Let me open one very basic ROS2 node available in RCLPY GitHub repo. The link is given in the description. RCLPY is a Python client library for ROS2 that provides a Python interface to the underlying ROS2 middleware. It is important to note that the main method uses the try except block to handle the exception and ensure the clean output when the node is killed. We see that a typical ROS2 node program are grouped in three key methods. The first method is the main method. It is responsible for initializing the ROS system, creating the node, and keeping it alive. In the main method, the RCLPY.init method initializes the RCLPY library. This function must be called before using any other part of RCLPY because it sets up the necessary internal structure and configuration required for ROS2 node to function properly. Further, the second is the main method. It creates instance of the node class in the try block. Then we use RCLPY.spin function that effectively puts the node into event loop where it can handle incoming messages, service requests, timer callbacks, and other events. And next is the init method. The init method is the second group of the all three that we have just introduced. It initializes the interface which can be publisher or subscriber for topics, server and clients for services and actions, and sometimes we use it to set the timer as well as to invoke the callback functions. The third and last group is the callback method or any other method to process the data. The timer callback function is called periodically to publish the message on the basis of the frequency that is specified in the timer definition. Node class is defined in the RCLPY library. To explore the node class, we have to see the RCLPY documentation. So open the documentation using the link given in the description, or we may search for RCLPY Humble in any web browser. Click on the link under Client Library, click RCLPY Package, and then click on the link API/RCLPY index.html. You may notice that we are directed on a page which suggests rolling but not Humble distro of the ROS2. But it is fine, no problem. The documentation is valid for Humble as well. So click on the node to look into more details of the class. We see that except the node name, all other parameters are set with some default values. So when we create any subclass based on the node class, it is necessary to set at least node name using superint method, and that is what we are doing in all node subclasses. Also, there are many methods in the node class, and the instances of this class will have access to all these methods. Create publisher, subscriber, clients, servers, methods for parameter, timers are some of the important methods of this class. In the code that we are looking at, that is docker.py, we have created one publisher using create publisher method of the node class. The publisher is publishing on a chattered topic with string message type. After this, we use a create timer method to periodically call the timer callback for processing the message. The string message type is defined in the standard message interface package, and the field name used is data and field type is string. These are discussed in detail in the interfaces session later. In the timer callback function, create a message of string type and assign the hello word and the counter. Log this information using getLogger method of the node class with info type of output. Finally, we publish the message using publish method that we can see. Now we can run this default node as suggested using the ROS2 run command. We copy this command and paste on the terminal. ROS2 run examples underscore RCLPY underscore executor, then Docker. Here, the examples RCLPY executor is the package name and the Docker is the executable name. Note that the executable name may be different from the name of the node or the name of the Python file that we shall see when we create our own package in the later part of this video. Node name is set using superinit method as we have already done. The executable name is defined in the setup.py. You will see this as well in a while. We see that node has started publishing the messages. There are many more default nodes in different built-in packages. You can check the two packages which are commonly used to make it more clear. One is the TurtleSim and other is the demo nodes underscore py. So let us check the executables of TurtleSim by using ROS2 pkg executable TurtleSim. You can write ROS2, enter, it will help you to select pkg, then enter, it will help you to select executables, and then you have to provide the package name. So run one of the executables of TurtleSim, that is TurtleSim node, to start this TurtleSim package. And in another terminal, we can check the executables of demo nodes underscore py package and use the same ROS2 package executables, the package name, to see how many executables are there. And we will see here that we can, the Docker is appearing in this list. So we can run this in another terminal using ROS2 run and the package name demo nodes underscore py, Docker is the executable name. You see the other node with this name listener is also listed there, and let us run that in another terminal. You see that whatever is being published by the Docker in this terminal is being subscribed by the listener in the another terminal. Till now, we have used the available nodes to develop a basic understanding of nodes. Now it's time to run our custom node. But certainly we will take help of the node which is already there on the GitHub repo. For that, first step is to create a workspace in home directory using mkdir command. So we'll be creating ROS2 workspace. Change directory to ROS2 workspace using cd command, create src directory there, and then go to src directory. So now we can use ROS2 pkg once again to create the Python package. So we'll be using ROS2 pkg create command, and do not forget to specify the build type, else it will create cpp package. You may give test topic name to your package, but in detail we will be dealing with the package in a separate video. So now for now you follow the instructions only. Open this src folder in VS Code, create a new file, copy and paste the code and save as this. Next step is to add the dependencies in the package.xml. The import section gives you an idea of the dependencies of the packages and the libraries. The default Python packages are not part of the dependencies. For example, times, sys, or matplotlib, and so on and so forth. We see that RCLPY and snare messages are the two dependencies that you need to add. So we can open package.xml and add these two dependencies in depend tag. So once it is done, next step is to add the entry point in the setup.py. We define the executable name and the entry points here. We need to specify the package name and the file name here in this particular setup.py to define the executable name. So we can select pub_exe, that I use the convention of giving name to any executable as _exe. So I am giving pub for publisher, but you can give any name. Pub_exe, that is equal to a test topic, the name of the package, and publisher, and that is the name of the file, that is publisher.py. We are not giving extension here, only publisher is required. And then the name of the method where this should hit at the beginning. So after adding this, we have to save all the files before coming to the terminals which are open in VS Code, whether it is publisher.py or the package.xml or setup.py. Now, important step is to build that particular package. So we'll be using colcon build tool to build the package. Again, you have to follow the instructions. The detail about colcon build tool we'll discuss later. It is very important to note here that you have to make sure that you are in the workspace, not in the home or src folder or in any other folder, and use colcon build to build the package. So once the build is successful, we have to source the overlay environment using source install /setup.bash. We can also source local setup, but we'll be using setup.bash. It will take care of both underlay environment and overlay environment. You'll find 3 more folders in the workspace, namely install, build, and log. In case you build the package in any other folder by mistake, you should remove these folders using rm-rf install, build, and log. So now we are ready to run our node. Check. So for running the node, we have to specify the package name rows to run package name, that is test_topic, and then the executable name that we have specified in the setup.py, that was pub_exe, Python rows to node, and then the default packages and node, and then the custom node that we have created. And that is all for this session. If you find this video helpful, do not forget to like this video and subscribe for more such tutorial. Until next time, happy learning. Thank you.